By August, the tomatoes were dead in every way that mattered. Not collapsed, not rotted, not eaten by pests, just standing there in their raised bed, like monuments to effort that went nowhere, leaves curled inward, blossoms long since dropped, fruit that never came, and the soil on top was still wet. That was the part that made no sense at the time. You could press your thumb into the surface and feel moisture, see the dark color of damp earth, and still those plants looked like they had been abandoned in a drought. The person tending them had been out there every single morning before work, hose in hand, sometimes again after dinner, when the thermometer refused to drop below 95, twice a day during the worst stretches. More water. When things looked bad, more water. When it did not fix it, the logic felt airtight. Plants need water, soil looks dry in the heat, therefore water more, and the logic was a trap. Here is what that trap actually looks like when you finally stop trusting the surface and dig 8 inches down beneath a plant whose topsoil never dried out. Earth was powder, not slightly dry, not transitioning, just pure powder. The kind that crumbles between your fingers and holds no structure at all. The roots should have been driving 12 to 18 inches into the profile, reaching toward the cooler, more stable moisture reservoirs below the evaporation zone. Instead, they had clustered into a shallow mat in the top 3 inches. They went where the water was, they stayed where the water stayed, and every morning, watering session, every conscientious pass with the hose, was the precise signal that trained them to remain in the most dangerous location. The surface layer, that heats to tissue-damaging temperatures. The moment air hits triple digits. The layer that loses moisture to evaporation faster than any other zone. The layer that offers no buffer whatsoever when a heat dome settles in. And you cannot water at noon because you are in an office 20 miles away. This is not a story about someone who didn't care enough, which makes it useful. This is a story about someone who did everything the conventional script told them. Water regularly, water when it is hot, keep the soil moist, and produced a result indistinguishable from neglect. The plants yielded almost nothing. The water bill climbed. The time investment was real, daily, and non-negotiable, and the outcome was a row of organisms technically alive, but functionally starving. Starving for the one resource being poured onto them every 12 hours. That gap between effort and result is not a personal failure. It is a system failure, and it is replicated in millions of backyard gardens every summer by people following the same inherited watering logic that has never been examined against what water actually does once it leaves the end of a hose. What water does in soil is not what most people picture. The intuitive model is that water hits the surface and spreads outward and downward like a sponge absorbing a spill. But that model is wrong in almost every practical detail. Water moves downward under gravity through preferential flow paths, following channels of least resistance. The depth it reaches is determined by volume, speed, and soil structure. 60 seconds with a hose wetting a 2-foot diameter circle does not push moisture to 12 inches. It wets the top 2 to 3 inches and stops. The physics are non-negotiable. 1 inch of water measured at the surface delivered slowly enough to infiltrate rather than run off is what it takes to reach 12 inches of depth in a well-structured loam. That translates to 3 to 4 gallons for a single established root zone, delivered over 30 minutes to 2 hours, depending on whether you have clay that resists or sand that drains too fast. Nobody standing over a garden with a hose before their morning commute is delivering that volume at that rate. The daily ritual is not watering, it is wetting. And wetting is a fundamentally different act, with fundamentally different biological consequences. The consequences compound in exactly one direction. Shallow water trains, shallow roots. Shallow roots cannot access the deep soil reservoir that stays cool during heat events. That loses moisture to evaporation at a fraction of the surface rate. That buffers a plant through the conditions most likely to trigger blossom drop, leaf curl, fruit cracking, and outright death. Every day of surface watering is another day. The root system receives confirmation that depth is unnecessary, that the shallow zone will provide, and then July arrives and the shallow zone becomes a kill zone. The gardener adds more water to the kill zone, and the roots have no architecture to escape downward, Because they were never given a reason to build one, the system was designed to fail from the first watering. Not by the gardener, but by the advice and the assumption, by the inherited logic that treats visible wetness as proof of adequate irrigation. You were not failing to grow food. You were locked into a watering pattern that guaranteed you could not. Here is the thing nobody selling you a raised bed kit will ever print or put on the label of a bag of premium potting mix. The reason your soil cannot hold water below the first 3 inches has almost nothing to do with how often you water, and everything to do with what was killed before that bag was sealed shut. The soil you purchased, marketed as garden-ready and nutrient-rich, perfectly balanced for vegetables, arrived at your door already dead. Not dead in the way that sand is dead, inert and honest, but dead in the way that a sterilized operating room is dead, wiped clean of every organism that once made the system function without you, the mycorrhizal fungi that should have threaded through that soil, in networks stretching dozens of feet, the organisms whose entire evolutionary purpose is to transport water from deep reserves, to plant roots in exchange for sugars, were exterminated during the composting process. And the heat treatment, the mixing with peat stripped from bogs that took 10,000 years to form. You were sold a growing medium with no immune system and no circulatory system, and then you were told the solution to its inevitable failure was more product. This is where the dependency loop locks into place. A living soil, one that has never been bagged or treated or flipped by a rototiller, contains fungal hyphae, so fine and so extensive that a single cubic inch can hold 60,000 individual threads, each one capable of moving moisture laterally and vertically through the soil profile, independent of gravity, independent of your hose, independent of your schedule. Those networks do not simply exist alongside plant roots. They physically penetrate root cells, forming structures called arbuscules where the exchange happens directly. Water and phosphorus delivered to the plant, carbon sugars delivered to the fungus, a transaction that has been running without interruption for 400 million years. In every undisturbed soil on Earth, the moment you add synthetic fertilizer, particularly the high phosphorus blends sold for tomatoes and peppers, you short-circuit that transaction. The plant receives phosphorus for free without the fungal intermediary, and the signal to maintain the mycorrhizal partnership collapses. Within a single growing season of regular synthetic feeding, fungal colonization of roots drops by 40 to 70%. The network that moved water to your plants through drought, that extended their effective root zone by a factor of 10, that connected them to moisture reserves 18 inches below the surface, goes silent, and now you need the hose. Now you need it every single morning. The same destruction runs through every other conventional practice, stacked into the standard gardening advice, tilling, which every spring preparation guide treats as essential maintenance, physically shreds fungal hyphae that took an entire season to establish. One pass with a rototiller resets the fungal network to zero. The bacteria recover in weeks. The fungi need months, sometimes years, to rebuild the same architecture, and they will never rebuild it if you till again next spring. Herbicides marketed as safe for garden paths and bed edges do not stop at the border you sprayed. Glyphosate, the active compound in nearly every consumer herbicide product, is a systemic chelator that binds manganese, zinc, and iron in the soil, starving the very microorganisms responsible for decomposing organic matter into stable humus, the substance that gives soil its water-holding capacity. You spray the path, the chemistry migrates with rain into your bed, and the soil's ability to retain moisture at depth quietly degrades. While the surface still looks dark and rich, there is a moment every July when the gardener 2 doors down watches her tomatoes hold steady through a week of 100-degree air, while everything else on the block wilts into gray surrender, and she cannot explain it because the answer is not visible at the surface. The answer is 12 inches underground in a thermal zone, 15 to 20 degrees Fahrenheit cooler than the scorched top layer, where moisture sits undisturbed by evaporation, where roots she trained months earlier are drawing on a reservoir that no amount of afternoon hose spraying could ever replicate. That is not gardening luck. That is a piece of biological code, written into every plant on Earth, a code that most modern growers have accidentally switched off by doing exactly what feels responsible, the code. Works like this. Soil is not a uniform sponge, it is a vertical gradient, and plants read that gradient the way a compass needle reads magnetic north, when the top 2 to 3 inches go dry while moisture persists at depth. Root cells at the growing tip detect the differential and extend downward, following the signal like a wire following current. Every inch of downward growth moves the root system into progressively cooler, more stable territory, where surface heat waves become irrelevant background noise. The plant does not need more water. It needs water placed correctly in the vertical column. So the gradient signal stays active and the architecture keeps building deeper. The moment you wet the surface every day, you erase that gradient entirely. The upper profile stays consistently moist, the lower profile stays dry, and the root system receives no directional signal at all. It clusters in the top few inches like a satellite dish pointed at static, drawing from the one zone most vulnerable to heat, evaporation, and biological collapse. Deep, infrequent watering is not a watering schedule. It is a root training protocol disguised as a watering schedule. You push moisture 12 to 18 inches into the profile in a single slow session, then you walk away in sandy soil during peak summer. That means returning every 3 to 4 days, in loam every 5 to 7, in clay. Dominant ground that holds moisture longer, 7 to 10 days once plants establish. The calibration tool is a probe pushed to root depth before each session. You want moist but not saturated at the bottom, dry or barely damp in the top 3 inches. That specific combination, dry surface over moist depth, is the signature of a system, where the gradient signal is broadcasting clearly, and roots are responding. Mulch enters here not as a cosmetic layer, but as structural infrastructure that makes the entire mechanism viable. 3 to 4 inches of organic material applied immediately after a deep watering event cuts evaporative loss from the surface by 40 to 60% in hot, dry conditions. Without it, a significant fraction of every watering session flashes off into the atmosphere before gravity can pull it to root depth. Straw, shredded leaves, wood chips, all function. Fine textured materials seal tighter, with fewer air gaps. Coarser chips last longer across seasons for perennial systems. The mulch is not protecting the soil from the sun in some vague, nurturing sense. It is extending the window during which applied water can physically travel downward, past the evaporation zone and into the cool, stable layer where roots are waiting for it. There is a transition cost that kills the technique for most people before it ever delivers results. A plant grown under daily surface watering has its entire root mass clustered in the top inches. When you shift to deep, infrequent delivery, that plant loses access to its current moisture zone for several days. While its roots have not yet reached the new one, it wilts. It looks worse than before. 1 to 3 weeks of visible stress is normal during this architectural rebuild. And the correct response is to hold position, not retreat. Cutting depth back to the surface restarts the cycle from zero. The plants that survive that transition window emerge with a fundamentally different relationship to heat when air temperatures spike into conditions that trigger blossom drop and leaf curl in shallow-rooted neighbors. Deeply rooted plants draw continuously on a moisture reserve, insulated from surface extremes, maintain turgor pressure in leaves and stems, sustain pollination and fruit set, and do all of it on significantly less total water than the daily surface schedule ever delivered. This is the part that breaks the logic most people carry into their gardens. Less water, applied less often, at greater depth, with a mulch cap holding the system closed, produces more resilience than any amount of daily attention with a hose. The mechanism is not mysterious, it is physics, gravity, and a root signaling response that every plant already possesses. The only thing required to activate it is the willingness to stop interrupting it. And once that architecture is in place, Once roots occupy the cool deep zone and mulch seals the surface. The entire system begins to function as a buffer against exactly the kind of prolonged dry stress that is becoming the defining constraint of productive growing in most regions. 5 years from now, the garden that requires almost no watering from you, will not be the one where you installed the most expensive drip system or ran the most precise timer schedule. It will be the one where you did something that looked like neglect. To every neighbor watching, you stopped watering the surface. You piled cardboard and dead leaves over bare soil until it looked like you had given up. You buried kitchen scraps and rotten branches directly into shallow trenches and walked away. And the ground, left alone under that ugly blanket of decomposing waste, began doing something it cannot do when you stand over it with a hose. Every morning, it started building itself into a reservoir. Here is what actually happened beneath that cardboard. The moisture you used to spray across the top 2 inches every single day, the moisture that evaporated before noon, that trained every root in your bed to cluster at the surface, like addicts waiting for their next fix. That moisture stopped arriving, and instead of dying, the roots did what roots do when surface water disappears. They push downward 8 inches, 12 inches, into the cool, stable, evaporation protected zone where temperature swings flatten out, and where moisture, once it arrives, stays available for weeks rather than hours. You did not engineer that response, you simply removed what was preventing it. The daily watering was the obstacle. The cardboard and leaf litter were not a technique. They were permission for the soil to stop losing what it already had. The math on this is not subtle. 1% more organic matter in your soil, the kind that builds passively under a permanent mulch layer made of materials you pulled from your own curb on trash night, increases the water holding capacity of that ground by tens of thousands of gallons per acre. You do not need an acre, even in a small raised bed. That shift means the difference between watering every 2 days and watering every 10. Between a system that collapses the week you go on vacation and one that holds steady through a full month of heat without you touching it. The person who was out there with a hose every morning before work, sweating through their shirt at 6 a.m., convinced they were being a good gardener, was actually preventing the very resilience they were trying to create. Every shallow drink they delivered told those roots there was no reason to go deeper, no reason to build the architecture that would eventually make supplemental watering almost irrelevant. Now consider what happens in that deeper zone once roots arrive, and moisture persists. Mycorrhizal fungi, the network organisms that extend a plant's nutrient reach by orders of magnitude, require exactly 2 conditions to establish: consistent moisture and active root presence below the surface layer. A shallow watered garden never provides both at the same time in the same place. The fungal networks cannot form in soil that dries and re-wets on a daily cycle at 2 inches deep, but a garden where water arrives slowly, deeply, and infrequently, where mulch suppresses evaporation and organic matter holds what penetrates. That garden develops fungal infrastructure that feeds plants from reserves no surface watered root system can access. You did not install that network. You did not buy it. You created the conditions for it by doing less, by watering less often, by leaving organic debris where conventional advice tells you to rake it clean. The perennial crops in a system like this, the fruit shrubs and food trees planted once and managed with deep watering only during their first 2 establishment seasons, become functionally self-sufficient by year 3. Their roots reach subsoil moisture that annual vegetables never touch. They perform hydraulic lift, pulling water from deep, moist layers toward the surface during drought, passively irrigating the shallow rooted annuals planted around their base. A food tree you watered deeply twice month for 2 years becomes a permanent water pump that operates without electricity, without timers, without your attention. The entire system begins running on its own logic, compounding biological capital season after season, requiring less from you each year rather than more. This is the lever, not a product, not a subscription, not a weekend construction project. A few flattened boxes from your recycling bin laid over bare ground, a pile of autumn leaves, your municipality bags and leaves at the curb for free, kitchen scraps buried in a shallow trench and covered, the refusal to water daily. These actions, bundled together, cost less than $10 and require no electricity or pressure. Picture the moment clearly. A winter storm knocks out power across 3 counties, roads close, the grocery store if it opens at all, has been stripped of produce within the first 4 hours. Your neighbor is standing in a parking lot at 6 in the morning, engine running, waiting for a delivery truck that may or may not arrive, hoping to secure a bag of wilted lettuce and some tomatoes. Shipped from 1,000 miles away, you are not in that parking lot. You are in your backyard, brushing frost off a low tunnel, pulling kale that has been sweetening in the cold for weeks, digging carrots from beneath a thick layer, straw where the soil never froze, because the biology you built over 2 seasons is still generating heat at the microbial level. The difference between you and the person in that parking lot is not talent, not acreage, not money. The difference is that you stopped treating food production as a hobby and started treating it as infrastructure. The same way you treat a roof over your head or a lock on your door. Everything discussed before this moment, the deep watering, the root architecture, the mulch layers, the soil organic matter above 4%, the fungal networks threading through undisturbed ground, olas and bucket drippers that cost almost nothing. All of it was never really about gardening technique. Technique was the vehicle. The destination was always this, a food system that does not require permission from a supply chain to feed you, a system where the plants themselves have been trained, through deep moisture and biological soil, to survive without your constant intervention, which means they also survive when you cannot get to them for a week, because the world outside your fence has become unpredictable. The person who waters daily from a hose, who depends on synthetic fertilizer delivered by truck, who replants from nursery starts every spring because their soil cannot sustain a self-seeding ecosystem. That person has not escaped the industrial food system. They have merely built a smaller, more labor-intensive replica of it in their backyard. They are still dependent. The dependency just wears different clothes. When the pressure comes, when the heat dome sits for 2 weeks, or the supply chain stutters, or the price of a single pepper at the store crosses $3, their garden fails at exactly the same moment the store fails, because both systems were built on the same fragile assumptions: constant external inputs, uninterrupted human labor, and stable conditions that no longer exist. What you have built is different in kind, not just in degree. A garden where roots reach 14 inches into cool, biologically active soil does not collapse when you miss a week. A food system mulched with 4 inches of organic matter and supported by mycorrhizal networks that move water laterally between plants does not panic when rainfall stops for 20 days. A perennial food forest with nitrogen-fixing understory and self-seeding annuals filling every gap does not require you to start from zero each spring, buying seeds and starts and amendments from the same supply chain. You were supposedly trying to escape. The system sustains itself because you designed it to sustain itself. And that design choice is not a gardening preference. It is a political act. It is the decision to place your family's access to real, nutrient-dense food outside the reach of price spikes, logistics failures, and the slow erosion of quality that defines industrial produce. This was never about whether you enjoy gardening. It was never about aesthetics or relaxation, or the satisfaction of a ripe tomato in August. Those things are real, but they are not the point. The point is that you live inside a system designed to make food production someone else's problem, and that design works perfectly until it does not, when it stops working. The people who reclaimed the knowledge, who built the soil, who trained the roots deep, and let the biology do the heavy lifting, those people eat